Today, I'm going to show you how to build an AI assistant API that business can actually use for support, internal knowledge, and automation. Most people stop at simple AI demos, but this project is different. We're not just calling an AI model for fun. We are building the foundation of a production-style AI service that can later be containerized using Docker, automate with CI/CD, push to Azure Container Registry, and deploy to the cloud. The goal is to build an AI assistant that accepts users' messages through an API, send them to an LLM provider, and return a response in a clean, usable format. This is important because knowing how to use AI is one thing, but knowing how to build and deploy AI system properly is a completely different skill. In this video, we'll start by setting up the FastAPI project, creating the AI chat endpoint, testing it locally, and preparing the application for the next stage of the infrastructure journey. Before we start coding, let me show you the flow of what we are building. At a high level, the system is simple. A user sends a message to our API. Our FastAPI service receives that message, process the request, and send them back to an LLM provider. The model generates a response, send it back to our FastAPI app, and then our API returns that answer to the user. Right now, we are focusing on the application layer only. That means we are not dealing with Docker, CI/CD, Azure, or deployment yet. The goal at the first stage is to build the core AI assistant API and make sure it works locally. Once the foundation is working, then we can start productionizing it by containerizing it with Docker, pushing it to GitHub, automating it with GitHub Actions, storing the image in Azure Container Registry, and deploying it to Azure. So I want you to think of this video as building the brain and the API interface first. Infrastructure comes later. So without wasting your time, let's get into it. First and foremost, I'm going to create the project folder for the AI assistant. I want to keep the structure clean from beginning because the project will grow later. We're going to name this folder Nimbus AI Assistant, and that's what we're going to call this AI assistant, Nimbus AI Assistant. Next, I'm going to create a Python virtual environment. This isolates the dependency for this project so they don't interfere with anything else in my machine. So we can see the virtual environment. So the next thing I'm going to do is that I'm going to run this command line, and what this command line does is that it's going to install the main package that we need. FastAPI gives us the API framework. Uvcon runs the application locally. OpenAI lets us connect to the model provider, and Python.env helps us to load the environment variable like API key securely. Now, when I run pip freeze, it saves all the installed dependencies and their version into requirement.txt. This is important because when someone else runs this project or when we build a Docker container later, we want the exact same environment that we used during the development. That gives us our dependencies. So we are going to go straight to creating our application folder and files that we are going to need for this project. So I'm going to run this command, and this command creates our folder for application and .env where we are going to store our OpenAI keys, and .gitignore is so much important that you implement .gitignore because we don't want our sensitive information to get pushed to GitHub. So this stops our .env that's going to contain our API key from being pushed to GitHub. Also, venv from pushing to the GitHub. So understand how to use .gitignore is one of the security best practice in SDLC, software development lifecycle. It let you know to push your sensitive information into GitHub. Even if your GitHub is private, you don't have to push it to GitHub. So the next thing we are going to do is that we are going to go to .env and we are going to implement our Open API key here. So when I come to Open AI, I'm going to head straight to API key. Then I'm going to generate a new key that I'm going to use. So I will just name it test2. Then I will generate the key. I'm going to implement it into .env. Now, coming to the application code, this is where I'm going to impute all the application code. I'm going to explain all this code so that you understand what each of these actually, what it actually means. So, looking at import OS, I need the OS for environment variables .env to load the .env files, FastAPI itself, and OpenAI client, and pendant so that I can validate incoming request data. Here I'm loading environment variable from .env file so the application can read the API key securely. Now looking at the API key, this reads the OpenAI API key from the environment instead of hard coding it to the source code, because you can easily pull the API key here, but which is not the best practice. The best practice is to understand how to use .env and put your secret information there, then reference into the application code or wherever you want to reference it on. So when we containerize this application, we are not going to leave sensitive information, secret or key, anything in our artifact. On the next part, it says create OpenAI client. This create the OpenAI client that our API we use to send requests to the model provider. Second one says app. This initialize the FastAPI application itself. Now looking at the chat requests, I'm defining a request model here using Pydantic. This makes sure every request to the chat endpoint has a message field and it keeps the API structured. The next is head. This is the head endpoint. It's simple, but in RAID system, this is important because it gives you a quick way to check whether the service is alive. The next goes to the chat. The chat, this is the main endpoint of the assistant. A user sends a message, we forward it to the language model and return the generated response back through the API. For the model, we are using GPT-4o mini. It's lightweight model here, so it keeps the project fast and practical for development. We might have to upgrade to a new model in the future, but we're just leaving it at the moment. The message part is the prompt place. I'm also setting up a system instruction to the assistant behaves like a technical helper instead of like completely generic chatbot. The except, finally, I'm wrapping the model call in a try except block so the API returns a proper error response if something goes wrong. So I'm going to head straight and run the application. So this code basically what it does is that it's going to run the application locally with UVCon and test both endpoints. So application is now running locally. We're going to go to the website and check the heads. After we check the heads, everything is working. Then we're going to go to the doc, the body part of it, and communicate with our AI. So this is the head check. Start is okay. Start Nimbus AI assistant. The next part is that we're going to test the chat endpoint in a Swagger UI. FastAPI gives us a Swagger UI out of the box, which is really useful for testing APIs quickly. It's just removing the head and putting doc, and this is the chat place. So let's get straight and test the charts. We'll head straight to here and I'll say try out. On the message part, I'm going to basically put explain Docker like I'm a beginner. Then I'm going to execute it and we're going to see the responder is going to give us back from the LLM. So this is the response. Basically the question, explain Docker like I'm a beginner. Sure. Imagine you want to run an application like a web service on your computer. Normally you would have to install all the necessary software and dependencies directly on your computer, just like I did locally, which can be complicated and can load to perform. If I give you the code, you won't be able to run it because you now need to download the dependencies on your computer. So basically, Docker helps us to package all the dependencies. Remember when I said I'm packaging the dependencies so that when I'm creating a Docker file, it's going to package everything in a Docker file in something we call artifact. So that's basically what's Docker. Now, before we leave here, just one more thing. Do you know about boss? Let's know if an AI knows about my company. So here I execute it, and what does it say? It says, as of my last knowledge updated in October 2023, Nimbus Compute Ltd is known for providing cloud computing solution, particularly focused on infrastructure as a service, IaaS, and platform as a service. Bro, Nimbus Compute knows about us. So anyway, if we go back to our code, we can see the response on the terminal, running on the terminal. So at this point, the core AI assistant is working. A user send a message to our FastAPI API. Our backend send that request to the language model, and then the response comes back through our API as a structure JSON. So basically, in this video, we built our first version of our AI assistant API using FastAPI and OpenAI. We created the project structure, added a heads endpoint, built the main chat endpoint, connected it to the model provider, and tested everything locally. In the next video, we're going to containerize this application with Docker so it can run consistently across environments and move one step closer to production. Looking at this project, you will notice that I'm actually using OpenAI. That's what I'm using for the MVP. Later in the production, I can migrate it to Azure OpenAI. But for now, I'm using OpenAI. Yeah, before I forget, if you want the full project repo and more reward DevOps project and AI infrastructure build like this, you can join my school community where I teach everything about AI infrastructure, DevOps, DevSecOps, cloud engineer, platform engineer, and also you can join my Discord free. The link is on my bio. See you on the next one, and thank you for watching.